Hello. Hello. Okay. So in this lecture, I'm going to discuss about the three important things of JK flip-flop, and these are truth table, characteristics equation, and excitation table. So these three things I'm going to discuss in this lecture. So first of all, just brief idea of JK flip-flop. You know, JK flip-flop has two inputs. One of the input is known as J, other input is K, and it has two outputs. One is Q1 and other one is Q1 bar. Okay. And as it is a flip-flop, it will have a clock input. By default, for every flip-flop, clock input should be there. Okay. Now, how to find out the truth table for JK flip-flop or for any other flip-flop also? What principle we need to follow in order to find out truth table? The input will be given to us and the present state or present output will be given to us. And based on that, what will be the next output that we need to identify? So how my output is getting changed? That is changed by applying the clock. So if you apply the clock, then only your output will be getting changed. So if your present output is Q1, after applying the clock, the output will be known as Qn plus 1. And same thing is applicable for the bar output. Okay. So in truth table, what are the things are given to us? Three things. J, input J value, input K value, and what is the present output. And based on these three things, we need to find out what will be the next output. Next output means after applying the clock, whatever the output you are getting in this terminal, that is known as Qn plus 1. Okay. Now, so as we have three variables, we can make 8 combinations: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the 8 combinations. Okay, and this is the suppose clock signal. Okay. This arrow indicates the clock signal. Okay. Now, so try to find out what will be my Qn plus 1 value when J equal to 0 and K equal to 0. You know, this particular thing when J is equal to 0 and K is also 0. These two cases. Okay, where J is also 0, K is also 0. This is known as, you can write some comment also. You can write some comment also. This particular combination is known as no change. No change state. So it means no change means whatever the present output you are having, after applying the clock, you'll be having the same output only. Okay, when J equal to 0, K equal to 0. So in this condition, if your present output is 0, the next output will also be 0. If your present output is 1, the next output will also be 1 after applying the clock. Okay, so this particular thing is known as no change state. Okay, now check the next two combination. The next two is J equal to 0, K equal to 1. This particular thing is known as reset. Okay, when J equal to 0, K equal to 1 is applied, this is known as reset. So what is the meaning of reset? Whatever may be your present output, after applying the clock, the output will be definitely by default it will be 0. Okay, this is known as reset. Okay, so what does it mean? When you are applying J equal to 0, K equal to 1, whatever may be your present output, after applying the clock, the next output will be automatically it will be 0. And this particular thing is known as reset. when j equal to 0 and k equal to 1. Now check the next combination. When j equal to 1, this combination you check j equal to 1 and k equal to 0. Now this particular combination is known as set state. So what is set? Set means whatever may be my present output, after applying the clock, my next output will be definitely 1. Okay. So when j equal to 1 means if your input j equal to 1 and k equal to 0, if these values you are applying, then after applying the clock, immediately your output will be 1. Whatever may be your present output, it can be 0, it can be 1. However, after applying the clock, the next output means qn plus 1 will be definitely 1. And this particular thing is known as set state. Now come to the last combination, that is 1. If j equal to 1, k equal to 1. Okay, so this particular thing is known as toggle. You know, you can remember in case of SR, this particular combination was not possible. Now this is possible in case of JK. You can apply j equal to 1, k equal to 1. And this particular thing, this particular state is known as toggle. Now what is toggle? If your j equal to 1, k equal to 1, at that time, whatever the present input you are having, after applying the clock, the next output will be the inverse version of the present output. So what is the meaning of this line? Suppose your present output is 0. After applying the clock, your next output will be 1. And suppose your present output is 1. After applying the clock, the next output will be 0. So this means toggle. Okay, toggle means your output, currently whatever output you are having, after applying the clock, the inverse version of the output you will get. Okay, when you will have j equal to 1 and k equal to 1. Okay, so this is the truth table of JK flip-flop, and using this truth table, we can easily find out the characteristic equation. How? You have to use the K-map. Use the K-map. In the K-map, 3 variables you need to use. That is J, K, and Qn. These things are given to you, and you need to find out the value of Qn plus 1 means next state value you need to find out. Okay. It means after applying the clock, what output you are getting, that you need to find out, and that is denoted by Qn plus 1. Okay. So make the truth table. Oh, so find out the value of Qn plus 1. So that is 0, 1, 0, 0, 0, 1, 0, 0. Then you have 1, 1, then 1, then 0. Okay. So you have this combination and try to find out what will be the equation. So we can make a combination using this 2 1, and from this 2 1 means if we make some pair, what will be the equation? That is j, and from the top what it will come, q bar, qn bar. Okay, and for this 2 1, what you will get? We will get k bar qn. Okay, and this particular equation is known as characteristic equation of JK flip-flop. Okay, now I'll discuss about the third part. Discuss about the excitation table. Now, if I followed the last lecture, means where I discuss about the SR flip-flop, I told if you have the truth table, you can easily make the excitation table. So same thing is applicable for each of the flip-flop. So now I'll make excitation table. So what is excitation table? If the present state and next state is given to you, means if the present state output and the next state output is given to you, using these two things, you need to determine the value of input. Now in this case, the inputs are J and K. This particular thing is known as excitation table. Excitation table. Okay. So in this case, this thing will be given to you. Present state and next state outputs are given to you. You need to identify the value of j and k. Okay. And this thing is known as excitation table. So you have two variables, four combinations. You can make 0, 0, 0, 1, 1, 0, 1, 1 as you are given qn and q plus 1. From there, you need to identify j and k. Now, how to find out the excitation table? So you see the truth table. How many times this 0, 0 combination came in qn and qn plus 1? Here one time and here one time. Now, in each of the case, see what is the value of j and k. So in this case, j equal to 0, k equal to 0. And in this case, j equal to 0, k equal to 1. So from these two conditions, what you can see, the j value is remain fixed to 0. So you write it the value, write down the value. J is remaining fixed to 0, whereas k value, sometime it is 0, sometime it is 1. So what does it mean? It is not depending on the value of k. So you can consider k as don't care. Okay. Now follow the same thing for the next combination. Next combination is 0, 1. So you see 0, 1, how many times you are having in this truth table? 0, 1. This is one time and this one time, two times. So you see in these two cases, what are the values of j and k? So here j value is 1, k equal to 0. And in this case, j equal to 1, k equal to 1. So in these two cases, what you have observed, j value is remain fixed at 1, whereas k value, sometime it is 0, sometime it is 1. Means that it is not depending on the value of k. So the value will be 1, don't care. Now do the same thing for the third combination. So that is 1, 0. Try to find out how many times you got 1, 0 in the truth table. One time here, 1, 0 anywhere else here. So two times you got. Check the corresponding values of j and k. This and this combination. So here you can see j, sometime it is 0, sometime it is 1, whereas k is 1 in both the cases. So it means that don't care 1. Okay. Now follow the same procedure for the last combination. It's 1, 1. Check how many times you got 1, 1. Here one time, here one time. And the corresponding JK combination, here it is 0, 0, and here it is 1, 0. So what does it mean? J, sometime it is 1, sometime it is 0, whereas K is fixed at 0. So what you need to write? Don't care 0. Because J value, it is not depending on, means the, if your Qn and Qn plus value combination is 1, 1, in that case, you see the J value is 0 here, here 1. It means that it is not depending on the value of J. So that's why I've written don't care. And for the K, in both the cases, you see the K value is remain fixed, and that is 0, 1. Okay, so this is the excitation table. Thank you.